The water tank is built in the shape of a circular cone with a height of 5 meters and a diameter of 6, which would make the radius 3. I can put 6 all the way across like that. Water is being pumped into the tank at a rate of 1.6 meters cubed per minute, so we are told that volume must be a function of time, and we're told at how fast the volume is getting pumped in. We want to find dH/dt, which also tells us that height is a function of time. At a height of 2 meters. So first thing that I do sometimes in questions like this, I just do a quick check on the units to make sure all the units that are being used are the same. Because like I said last class, if you don't check that and you do a whole question, you're going to get it wrong and then go, oh, I have to redo everything because of the units. Once again, what we have here is water coming in. I'm going to make my water green just so I can see a different color. It's not very clean water. And this water is going to be a similar triangle to the larger triangle. So we're going to have the same ratios that are present. We need to come up with a formula. Our formula that we have in this situation is going to deal with volume. Volume of a cone is 1/3 the volume of a cylinder, so it's 1/3 pi r squared h. And here we notice that we have another variable in the equation. So we're going to have to try to substitute out the variable r for the variable h. Okay? Now we have a ratio. Okay, the ratio of the radius to the height is the same as 3 to 5. We write these as fractions. You can get the radius by itself to be 3 times h divided by 5, which will allow us square this. We're going to have 1/3 times pi times 9h squared over 25 times h. And if we simplify this, we're going to get 3h cubed, 3 pi h cubed over 25. Now we can take the derivative with respect to time of this whole equation. So again, we do our derivative rules with implicit differentiation. So after you do your regular derivatives, you're going to have to add dv dt and dh dt. And now we can solve this. We know that dv dt was 1.6. And at h equals 2, but I did take, oh, yes, you're right. But I did simplify the 9 and the 3.
Oh, okay.
So if you kept the 75 on the bottom and you kept the 9 on the top, it'll work out exactly the same. Did you keep the 9 on the top?
I did.
Yeah, so that'll be exactly the same. Yeah, so the question was, If there's 3 times 25 y's and it's 75 on the bottom, I did simplify the 9 and the 3. And you had 3 on the top, but if you kept the 9 on the top, it would be identical. And then at this point, we go to our calculator. We're going to have to multiply both sides by 25. And we get, I got dHdt equals 0.354. And our units were meters per minute. Does that match what I had written at least?
Yeah.
It does? Perfect. Again, careful when even you do your calculations part. Sometimes there can be problems simplifying here. Check that with your calculator. Because if you got to this point and your answer's wrong, then that means you're doing some sort of calculation order operations error on your calculator.